Hello, everyone. I'm JJ, a product manager of Ryzen Energy. Happy to be here and present you our company and also our products. And to begin, I will deliver overview of our company and show you what we do and how we do. Yeah. Ryzen Energy is one of PIN manufacturer dive into industrial over more than 20 years. And we're offering all kinds of product solutions, including residential, commercial, industrial, rooftop, and as well as utility scale project. And among all our products we are providing, our champion product, we will say that head junction product. And we are also the pioneer who brings this technology from lab to the mass production. We start our R&D back to 2018, which is 7 years ago. And in the next 7 years, we've been continuously working on this technology and break this world record for this model efficiency for 5 times. And just in last week, our updated record has reaching for 767.38 watt, which means model efficiency is already 24.7%, and it's over a bottleneck efficiency for the POC technology, 24.5%. Yeah. And to support all our R&D and mass production, we just established 2 new facilities only for head junction production, including cells and models. And we are also integrated manufacturer who has production of raw material or silicon, ingot, wafer slicing, and also as well as cell productions. Yeah, we have in total 8 production bases. 7 in China and 1 in Malaysia, and those 2 for the head junction production was all in China, south part. And with years of R&Ds, we have made a lot of achievement. And those was saying things was we have adopt zero busbar technology in the head junction production, and we are also the first one to reduce our wafer thickness to 100 micrometers, and we also reduce our silver consumption, which is also a huge part of cost structure of solar cell to lower than 7 micrometer per grams. And even now, for now, we see that the silver consumption has been lower to less than PORC. That's why we can now narrow down the price difference between our head junction technology to TOPCon or even to PORC. And we see by end of this year, the price level of head junction will be the same to the TOPCon. And here are some main new advancement we have made for the head junction technology. First thing that out of head junction natures, it is very sensitive to the high temperature. So all the high temperature process for the TOPCon head PORC cannot be adopted for head junction. So the first thing we do is to switching the cell cutting technology to the wafer cutting technology, because we know the cutting technology we use is local laser, which is over 400 degrees. And for head junction, we can only stand a temperature below than 230 degrees. So we switch the cutting process from cell to the wafer. So we can avoid this high temperature destruction on the cell structures. And secondly, we're also seeing the wafer thickness. According to all the studies, we know that optimal efficiency for head junction technology will be achieved by 80 micrometers. And for conventional solar cells, they have 150s, 130s, which is much thinner, thicker, and also with higher price for the raw material consumptions. And by thinning the wafer, in one way we improve efficiency, and on the other hand, we also improve the reliability and flexibility of the model of the cells. As you can see, we have done some tests to verify this flexibility and bendability of our cylinder wafers. And when the solar cell thickness reaching 90 micrometers, and we can give force in the middle of the solar cell, and some deformation can be caused. And in this test, even though we are reaching the maximum of the test device, which is 98.56 millimeter, the cell still remain intact. which means under, like, as I mentioned before, the model have become bigger and bigger. It cannot be avoided that some deformation will be happening in the middle of the cells, in the models. So with the better bendability and flexibility, when the model become bigger, if there's some bending, we have more resistant to some power loss caused by some deformations. And the other thing we do is changing from the conventional welding technology to zero bus bar technology. And by switching from SMPP to zero bus bar, we have using the thinner ribbons, so we have less shading on the front side. And we can have more ribbons on the front side, so we can have we can reduce a lot power loss caused by high resistance, and we have high conductivity, and we are also reduce a lot of silver consumption, because for the zero bus technology, we don't need some pad points to attach our ribbons on the surface, but using some adhesive materials to fix on the bus bar ribbons on the front side of surface. And also, by switching from SMPP to zero bus bar, no flux is needed for the interconnections. Thus, we can reduce some risk caused by residue or flux during the production steps. For example, some flux crystals on the solar cell surface causing some white spot or burning points, or causing some deformation things. And by changing from SMPP to zero bus bar, we also further reduce silver consumption, which I mentioned before, dramatically. From the from previous time, we have silver consumption for heterojunction technology over 20 microgram per gram per watt. But now, just by the Q2 of 2024, we have already reduced our silver consumption to 6 microgram per watt, which is even lower than PORC. And thus, the price for the model of the silver part, we also decreased from the original 8 RMB cents to nowadays 4.8. I think in the second half of this year, we will further reduce the silver consumption, reaching 4.4 RMB cent per watt. And we also optimize the structural design for the heterojunction from first generation to third generation, which we have now microcrystal silicon, amorphous silicon, and also the wafer in the middle. And with the optimization, we can improve the utilization rate of the infrared part lights and also ultraviolet parts. Thus, we can have better performance under low light or weak lights, and which means we have longer operation hours during the days, to offering higher energy yield. And so far, based on this advancements, we have launched our 2 products. One will be consist of 132 half-cut cell with a power output up to 725 watt. We see the maximum in this year. And the other one will be consist of 110 half-cut cell with a power output up to 605. Mainstream now will be 590, 595. And these are some advantage we have obtained with the heterojunction products. For example, we have the the highest bioefficiency factor among all the technology, up to 85%. 5% than TOPCon, 15% over PORC. And we also have the most stable temperature coefficient, which is only -0.24. Guarantees you the better performance under high temperature. We know that because of climate change, now the temperature in the summer times become higher. And the rated power we are providing is not the real power we are using in the application scenario. And with the lower temperature coefficient, we can guarantee a better gain for your project. And also need to mention that we have the lowest degradation among all technology, which means after 30 years power warranty, we still have 80 or 90.3% retention rate, much 3% higher than TOPCon, and we see 6% than PORC ones. Thus, we can, with improved efficiency and also the power generation gain, we can lower a lot the LCOE for the whole project, as well as BOS. And we also done some side tests to verify our product performance. These are some project cases we have running over the world. You can tell compared to the PORC ones, So our power generation in a year, in the first year, is like 4 to 7% higher. And this is okay. This is updated data from last year. We have like done some tests in Hainan, China, which is in south part, with average temperature around like 25 degrees over year. And we see here is average efficiency, average power generation gain is around like 5.3% higher compared to the PORC ones. And strange. Sorry, this presentation is something wrong. Yeah, here is a comparison between the different technologies. As you can see with heterojunction technology, because of like improved efficiency and also enhanced like power generation gain, we reduce a lot BOS and LCOE. And because with higher like efficiency, which means to reaching the same like installation capacity, less model pieces needed. And with less model pieces, we can reduce a lot, land use, mounting foundation piling, and cabling, inverter, and also labor cost and transportation costs. That's why it can reduce a lot, BOS costs and LCOE. And besides the conventional product design, we know that with a land constriction, we have like to apply our project in different like scenarios. Like the emerging market we have seen now is floating PV and also agriculture, which is more demanding on the better encapsulation for the models. Thus, we develop a new like solution for this application scenario. For example, we have like use double coated glass and specialized waterproof solution for heterojunction model, which means in the backside, in the junction box, on the like edges of the models, we will put some like special sealant and structure design as well. And we have also adopted some like corona treatment on the like junction box and our connectors. Thus, we can improve our resistance against the like corrosions. And with like improved solutions, we have also running some tests with the third parties, like TÜV or SGC, and also other like third parties to verify our performance under severe conditions, and all passed. And we have also adopted our product in this like different diversity application scenarios, like we have like in China, in desert, 22 megawatt. And also like project floating PV in German, which is near completion, 15 megawatt. And also other projects like distributed like Romania, Netherlands, Pakistan on rooftop, Thailand also on rooftops. Yeah. And so far we have distributed our shipments around 4 gigawatt only for heterojunction of the world. And to close, I would also talk about our like future plan for our like project. For this year, our target is to reaching like 430 watt models, and next year another 10 watt more. By 2027, we will also trying to combine our perovskite technologies to heterojunction technology, launching our first tandem cell models. By then, I think the model power output will be over 800 watt, efficiency up to like 30%. Thank you.